Which of the following component is more reactive in aqueous solution of sodium carbonate? If we go for the nature of sodium carbonate and the formula of sodium carbonate, this is sodium carbonate. We formulate it as Na2CO3, whereas the structure related information is Na2CO3. This is having sodium plus connectivity and sodium plus connectivity. We claim it as what? Na2CO3. It is a salt. What is this one? This is a salt. This salt is formed by the combination of strong base plus what? Weak acid combination is present. The dominated portion is what? Base. So therefore it is having basic nature. It is having basic nature, but this basic nature is relatively lesser. So therefore we can claim it as what? Weak basic in nature. That is weak basic in nature. Generally, what base will do is base will abstract the proton. It is utilized for the abstraction of proton. Whatever protons are there in the starting materials, those easily available protons, whichever are easily lost from the starting material to attain stability, those of all can be abstracted by the sodium bicarbonate related salts. Now the given question related to the starting materials and the effect of this weak mild base, that is sodium carbonate, let us have a look. Now the components given are, one is cyclopropene and reaction with aqueous sodium carbonate, cyclobutene and reaction with aqueous sodium carbonate, cyclopentadiene and reaction with aqueous sodium carbonate, cyclohexa 1,3 cyclohexadiene and reaction with sodium carbonate. Whereas if you look at this structure is now anti-aromatic in nature. This is anti-aromatic in nature. Whereas if it became as aromatic in nature, its stability increases. To increase stability, in order to increase its stability, it should become aromatic. That aromatic nature is possible if it attains Huckel conditions. It is possible if it attains Huckel conditions. What are meant by Huckel conditions are, yes, whatever the unsaturation is there, that can be extended from one part to the other part. That is, whatever the charge dispersion is there, charge dispersion can be extended from the starting position to the entire cyclic system, and it can reach to the initial state. Moreover, it should maintain planarity. The foremost condition is it should maintain planarity, and the last one is it should have the total number of participated mobile electrons. 4n plus 2 pi mobile electrons should be present. The n number of mobile electrons, this is mobile electrons. This mobile electron should becomes equal to 4n plus 2. N doesn't indicates the number, n is an integer, n can be 0, whole number, n can be 0, n can be 1, n can be 2, etc. So if these conditions are satisfied, this system will becomes what? Aromatic, and is possible if it loses proton. Suppose if it loses proton, as we said, it is acting as base. Yes, it is a base. It can abstract the proton. Whatever the CH bonds are there, one of the CH bond is broken in such a way that that sigma bond pair is accumulated over the carbon as carbon ion. That is C double bond C followed by C, H followed by what? This is having now lone pair. Now these two lone pairs can involve in conjugation. So therefore that system can move in the entire ring system. That is cyclic ring system formation, cyclic migration of the cations and the anions is possible, and it maintains planarity. Though it is sp3 hybridization, by force it becomes sp2 in nature, and it maintains total number of mobile electrons. Pi bond electrons are 2 pi bonds plus 1 lone pair. Total will becomes 4 plus 2 is equal to 6. This 6 will becomes equal to 4 into 1 plus 2. It matches with the Huckel conditions of 1, 2, 3. Hence it becomes aromatic. To become aromatic, in presence of mild base, weak base like sodium carbonate, it loses proton. Hence the species of given components like cyclopropene, cyclobutene, and 1,3 cyclopentadiene and 1,3 cyclohexadiene, out of these, the only one component that can react actively with respect to the given sodium carbonate is cyclopentadiene system. Cyclopentadiene system makes an intimate reaction with respect to the sodium carbonate. This doesn't react because To become aromatic, it should become cation. Cation formation is not possible because it is a base. If it makes an attack, it becomes anion. There is no use. Here also it doesn't becomes any kind of aromatic system. Here also it doesn't becomes any kind of aromatic system because this particular conjugation making followed by making of 6 electron equivalency is not possible in this case. Hence the only one given component that can reacts with the mild basic conditions of aqueous sodium carbonate is cyclopentadiene system. Only cyclopentadiene system.